All right, thank you. Good afternoon, everyone. Thank you for coming. My name is Jonathan Chittenden, and today we're going to cover some of the Amazon Web Services, some of their security mechanisms, and just also look at some of their common pitfalls in either their configuration or even in their implementation. And then we'll also look at how you can leverage some of these security mechanisms for defense in depth within your application. Then the final piece of the puzzle, I guess, would be we'll talk about Scout, AWS Scout, which is a tool that you can use to leverage some of these security mechanisms and just really look at easily assess your EC2 environment. So first, a quick introduction. I know I don't have a bio, and that's my fault, so I apologize for that. But I'm originally from San Antonio. I went to school in UTSA, and I actually ran into one of my classmates here. I used to be a professional gamer, and so this is me at a tournament, right? A professional gamer, what is that, right? So I spent a lot of time playing games, and then I soon realized, hey, I need to get a job. So at UTSA, I focused in forensics, incident response, and also reverse engineering. Around this time, I actually landed an internship with the Air Force at Lackland Air Force Base, and I did malware analysis. And then I also did some defensive programming. So that was a great opportunity. I met a lot of really great people and really got me started in security. Then I pursued my undergraduate at Polytechnic, and then I graduated from there, got into application security. So now I live in New York, and I work for ISEC Partners. So that's kind of like the past 10 years of my life. So with that out of the way, let's really just kind of get a high overview of what we'll be talking about today. So one of my first projects working for ISEC was to assess an application stack for a client that involved a lot of Amazon Web Services. And here we have three. These are by no means all of the Amazon Web Services. There's like 20 or 30. But some of them don't even provide any attack surface, so they're really not entirely interesting. So really, I just focused on EC2, S3, and part of S3 incorporates IAM. So the client had a ton of questions for us. This was like a new process for them. Before they hosted locally all their web production servers, their staging, their dev environment, and now they were pushing all of this out into EC2. And so they weren't entirely sure if they were even correctly implementing the security features that AWS provides. So this was pretty new to me as well. I spent a lot of time poring over documentation, and I ended up writing a couple of scripts to just help automate this process, some of the tasks that I had. And that was really the first breath, if you will, of Scout itself. So with that out of the way, let's talk about, and before I begin, right, so it's alphabet soup, right? There's a lot of acronyms out there. I'm going to be throwing them around. I'm going to do my best to clarify what they actually are. But at any point you have a question or I'm not entirely clear or I begin mumbling or something, feel free to stop me, ask me a question. If not, you can just come up here after the talk and ask me something privately if you need to. But again, let's talk about EC2 now. So right, EC2 is by far the most popular service, right? And it's pretty straightforward how you use it. At its most basic at its most basic level, what it does is it allows you to rent a virtual machine on Amazon resources, or their physical hardware. And there's four steps. So if you want to spin up an instance pretty quickly, you select your AMI, which is the Amazon machine image, and this is more or less your operating system. So Ubuntu, Windows Server, Red Hat, whatever it may be. Then you specify some instance details like, okay, what zone do I want it to be in? Asia Pacific, East Coast, West Coast, Europe. And then you also specify which kernel. And obviously, when you specify which kernel you want to use, it needs to be a kernel that ideally has all the latest and greatest security patches. That said, I'm pretty sure Amazon does a pretty good job of taking care of that. And then you select your key pair, or you generate a new key pair. And this allows you to remotely connect to your instance and configure it if you need to, or administer it. And then the last step, and this is really the bread and butter, is, in my opinion, is the security groups. And security groups are essentially firewall rules that dictate what traffic can be sent to your instance. So starting at the top, we have the AMI. And there's actually been a lot of security research here. And so I'm not really going to get into some of the nitty-gritty specifics, but I'll say this. When you're going to share your AMI with the community, do your due diligence and actually removing, you're cleaning out your bash history, for example. You may have stored passwords in there, removing certificates, or even keys that may be in your your SSH authorized key list. So some of the research that I've seen says that 30% of the community AMIs actually have passwords or other certificates in there, and that's an alarming number. I mean, that's a pretty large minority, right? Alternatively, if you're going to use a community AMI, again, you need to check for SSH authorized keys, because if I share an AMI and I put my SSH authorized key, maybe I just have something that beacons out to my server, and then lo and behold, I know that you just spun up my AMI, and now I can remotely connect to it. So these are all real security problems. A good rule of thumb is just to use Amazon's AMIs, and then you'll be fine. You don't really need to use the community AMIs for your web production server. So the next part of this is the EC2 key pair. And this, in my opinion, should be pretty obvious. But if you're going to use a single key for all your development team, why? Honestly, ask yourself that. Instead, you should have a unique key, a key tied to each user for your instances. And so if you have employee turnover, or a key gets compromised on their laptop, maybe it gets stolen or something, you can simply just automatically write up a script that will delete their key and then give them a new one. And so now, finally, we've come to the security groups. And again, I mentioned that essentially they dictate what rules and what traffic can be delivered to your instance. And so I have an example here. Does anybody want to take a shot at this? This is from the Amazon CLI interface, the command line interface. It's a little cryptic if you are looking at it for the first time, but maybe someone here has had some experience with it. Does anybody want to take a crack at it? All right. Go ahead. All right, someone.
Allows web traffic from anywhere.
Exactly.
Yes.
So, right, it's very basic. I break it up into 4 parts. The first part is simply just the security group name. So it's web servers here. Over here, the SG is just the security group identifier. The second part is the protocol. So it can be TCP, UDP, or ICMP. One of the interesting things about the security groups is that this is happening before traffic is even being routed, right? This is happening at Amazon's networking layer. These are permissions that they're routing. Amazon is actually routing the traffic. So even if you had an application or rather a host-based firewall, this traffic, if this is all you had, it's kind of redundant to have a host-based firewall. And then the third part is the to and from port. So this is the to port, and this is the from port. It could just as easily be 80 to 81, and that would open up 2 ports, right? That's pretty straightforward. And then the second part is the source. So here it's a CIDR notated IP, 0.0.0.0/0, and as the gentleman in the back mentioned, it's the entire internet. So as you would guess, this is a pretty standard security group. But where can things go wrong here? Well, it turns out they can go wrong. And this is a security bulletin that Amazon released following some black hat research by a group called SensePost. And what they showed, basically they tore apart Memcache. Memcache is used as a distributed memory caching system. It's very popular in cloud environments, and it's also pretty common in EC2 environments. So what they showed is you can anonymously and remotely hit the Memcache server and read and write to it, which is pretty alarming because if you think about your standard network segmentation, your Memcache server should not be on your perimeter at all. It should be tucked away within your network. It shouldn't be exposed to the internet. But lo and behold, SensePost released a tool that went around and crawled EC2 IP ranges looking for exposed memcached instances. So that's pretty alarming. It's so alarming that, again, Amazon had to release this. So how do you manage this? Well, you manage it through the security groups, right? Like I said, you would just apply a security group that would block traffic on port 11211. But again, yeah, it's not that clear cut because once you used to have a network diagram that was clear cut. You could see you had an actual physical separation between your servers and your routers. Now it's just all up in the cloud, and it's just kind of this ambiguous blob. You don't really know what's what. And so in my field as a consultant, oftentimes I feel like Lester from The Wire. All these pieces matter. And why they matter is because now you really do have your production, your staging, your development, your management, your database servers. They're all living pretty close to each other. And are they segmented to the exact same way that your traditional network layouts used to be? So how do you figure this out? How do you piece it together? Enter Scout. So Scout is a tool that a colleague and I began earlier this summer. We kind of demoed it a little bit at Arsenal at Black Hat. And it was a great experience. We really weren't too sure if people would be interested in something like this. But that said, we wrote it in Clojure using the Java library. And basically, at its most basic level, it'll help you audit your EC2 environment. So it's available in Git. This is the ISEC Partners Git, so you could hop on there, download the source, make changes. Buyer be warned, it does have some bugs in it. We are aware of that. This was just an early prototype. We're actually in the process of rewriting it entirely in Java. Question? So the new version, it will dump out VPC, but in the current version, no, unfortunately it doesn't. So I really won't be demoing the tool today because it really doesn't have any cool graphical output, and I don't want to bore you guys with just huge blobs of text. Really, it looks like nmap output, which is pretty straightforward. But so that said, I will talk about some of its functionality and give you some samples of what it'll look like. So at its most basic level, we wanted to help enhance manual analysis. And the way that we wanted to perform this was listing instances and their security groups, and then listing security groups in their instances. So here's a quick example. If you're just interested in the web server instance, you can dump all the security groups related to that, so production, staging, RDP. If you were looking at this, you might question, why is RDP applied to our web server? That's really not necessary, especially for a production web server. And so, if you saw this manual output, you could go and say, okay, I need to look at this a little bit further. Similarly, you may want to dump out a security group itself and say, okay, I want to know all the security group, all the instances that have this RDP security group applied to. So you see like a jump server and a web server. The jump server, just out of curiosity, does anybody know what a jump server is? Okay, great. So basically, it's just a server that you would connect to remotely administer the rest of your instances.
Question?
Yeah.
Can you compare Scout to Elastic Detector at all?
Elastic Detector. So my understanding about, and correct me if I'm wrong, but essentially what it does is it periodically pings your EC2 instances and checks to see if anything's been spun up while I guess you were away, right?
Yeah, it's one of the things you can do. So
Yeah. Yeah. I actually haven't used the tool much. I am familiar with it though. The idea between the two is a little bit different. This is more or less to help you, do some analysis. That's, in my opinion, more to detect nefarious things going on with your AWS account. But I mean, I might be wrong. Again, I haven't used it.
Can you repeat what the name of the tool was? Just Elastic Detector?
Yeah.
Okay. It's free. AMI, basically create a user within AWS. You give that user rights to the AMI from Elastic Detector. And they basically run the Amazon EC2 scripts to report to you everything you want. Close to the interface, send you an email, everything.
Yeah. So it's ideal for detecting if people are maybe you're asleep and they're spinning up instances and running up your EC2 bill without you knowing, basically. And yeah, it's a pretty cool idea. Yeah, and it actually came out pretty recently, I believe. So it's a pretty new tool. Automated analysis. So one thing we wanted to do was just audit groups and highlight potentially dangerous ingress permissions. Oftentimes developers will add things unknowingly and then just leave it there, or you might have a consultant like myself come in and require access to your production, and you'll grant me access and then you'll just forget about it, right? So the idea here is based on port ratings and based on the source, we'll give you some sort of magic value. So the port ratings, you provided a config file. It's just simply a JSON, and it'll say 1 through 5, and then you just specify ports that you want to rate at that level. 1 being the lowest, 5 being the highest. So 1, for example, might be 80 or 443, things that are pretty common for your EC2 instances. Something that might be high would be like Memcache, right? Or RDP, or maybe even SMTP, depending on how you use it. And then the source, if it's exposed to the entire internet, it's going to be rated higher than something that's just exposed to a single IP. So for example, a security group with 3389 open to the entire internet is going to be ranked higher than something open to 3389 to a very specific IP, a single IP. And so also what it'll do is it'll give you, it'll say critical finding, warning, or even just informational. And so critical are obviously things that you need to go and check out immediately. And then finally, compare groups. So you want to compare known good with reality. So what you can do is provide Scout with additional information, perhaps like a pristine configuration. Maybe when you first rolled out your EC2 instances, this is what it should have looked like. And then Scout will compare that with reality, diff the two, and then say, this is what's wrong, or this is what's really out there. Actually, one of the new things that we want to add is the ability to take snapshots of your environment, sort of like how maybe EC2 detector does. But you would take maybe Q1, Q2, Q3, and then just see, diff them and just see how your EC2 environment has grown, how it's changed over time. All right, so now we'll change gears. Do we have a question?
It's the stuff. You want to deploy it, you have to provide it, your access key and the secret.
Right.
Access.
Yeah, that's correct. And so the way we do that in Scout is you just provided a config file. And in there, ideally what you should do is just create a special user that just has access to read rather than actually make changes. But yeah, right, so then you would just provide the...
Yeah, I think you give stuff much quicker.
You think we do?
Yeah.
Well, I mean, that's a valid criticism. All right, so changing gears, let's look at S3 now. Simply put, you put an object in a bucket, and that's really it. So your object could be really anything. It could be an MP3, it could be a photo, it could be PDFs, whatever. And you put it in the bucket. In the bucket, you can just think of it as like a folder or something. It's just a container for all your objects, and you can access it through a number of different interfaces. So like, how would you use it? It's got a bunch of different uses. If you have a mobile application and you do photo uploading, right? You may want to use the REST API. Or if you do file sharing or maybe downloadable media and you want to save on bandwidth, you might use the BitTorrent interface. And obviously, both of these have like completely different security requirements as far as what you want to expose and how you want to enforce access controls. So access controls, there's 3 different ways in S3, ACL's bucket policy and the IAM policy. And these work in completely different ways. Yeah, I mean, they basically accomplish the same job, but you would use them in very different use cases. And then you can also in S3 do access logs, which is great if you want to look at metrics and see what's been downloaded the most number of times, what's eating up all my bandwidth, or even if you have an incident that you need to respond to, maybe S3, your HR bucket was exposed for a period of time and you can see what actually got accessed. And then the final piece is encryption, where you do client-side and server-side encryption. Again, these are very different, and you need to make sure that you're using the right tool for the right job. So let's start at the top and look at the ACLs. The ACLs are, I like to liken them to like a blunt instrument, because you either do a read or write, or rather, you also have read and write ACP, but that stands for access control policy, and we'll come back to that shortly. but you either do a read or a write, or you get full control. And then you also have your grantee, which could be an AWS account, so an authenticated user to AWS. And then you have, a predefined group also, so authenticated users, all users, and log delivery, which would be for, your access logs. All users, again, would be anonymous, so anybody could access that object or bucket. And so I have an example of a permission here that's pretty straightforward. It says grant all users permission to read to public photos. So if you wanted to do this in S3, you would do this through XML, but this is just, just a proof of concept. And this makes sense, right? So if you have a mobile application that, you share photos, and you want to be able to say, okay, everything in this bucket we share. So we have Woody here, and he takes all these awesome pictures of food, and then he shares them. Right, so this is great for ACLs because you have a lot of objects in a single bucket, right? And this will make sense again shortly. So, changing gears and looking at the bucket policy, this is a very precise instrument. And the reason why is because you can get very fine-grained permissions. So, for instance, here we have, this is the action, and then this is if conditional right here. So what you can do with that is you can get very specific and say, anybody can get this object through the torrent interface on this bucket if the time is between today at 3 and today at 4. And some other cool things that you can do is you can say, okay, I want to have a condition that says, make sure that any object that's uploaded to this bucket is encrypted server-side, or make sure that anytime there's a read or a write to this bucket, it goes over secure transport, so HTTPS, or even something as simple as allow read or write access only from this specific IP address. And so the way that this works is it doesn't use XML, it instead uses the JSON access policy language, which is kind of confusing if you first look at it. So confusing that Amazon ended up releasing this policy generator that you basically point and click, and it'll just generate the policy for you. So, right, if you're a record company, this permission might actually make sense because, say, Justin Bieber releases a new song, and you want to make sure that only people can access it between 3 and 4. And so, maybe it's a preview release or a preview track or something similar. And it gives you that fine-grained control. And then the final piece of the access controls is the IAM policy. And this is your fine-grained permission model. Again, you do this through the JSON policy language. But the weird thing is you create an IAM principal, so a user or a group, and then you attach IAM policies to it. Now, at this point, your eyes might be glazing over, and you're like, what did he just say to me? Now, so just bear with me. I'll actually break down what IAM is. So it's Identity Access Management, and it allows you to create users and groups that have access to your EC2 resources or your S3 resources or any of your other AWS resources. So for instance, you might want to create a user that has privileged access to your EC2 environment. That means he can spin up new instances, take down instances, modify details if you want, and then you might have a lesser privileged user that maybe can only simply read the details for certain instances. And you can also do this for S3, right? So you can say, I have a privileged account that can modify S3 buckets, delete them, so on and so forth. It also allows for identity federation, and this is great because it will sync up with your Active Directory, and so you don't actually have to create users yourself. Instead, it'll just use the users and groups that you already have in your Active Directory. So for instance, maybe you have a bunch of different departments and you're going to move all your organizational infrastructure into Amazon's web services. So EC2, you're going to use their buckets, you're just going to use everything. And you want to have your HR, you have an HR group, you have your sales group, you have your marketing group, and you have just different buckets and resources for all these different departments. Well, the beauty of it is you can just simply use your already pre-existing Active Directory and just simply create policies and attach them to these groups. And then that way you can ensure that the various departments only have access to the resources that you've permitted them to. So how should you use these? So tying it all together, ACLs again, they scale very well. Like you can use them for hundreds and thousands of objects within a bucket. Your bucket policy actually has a limit. It has a limit of 20 kilobytes, and so you can't really you can't use it on a mass scale like you can the ACLs. Also, the ACLs obviously have limited functionality. You can only do simple reads and writes, whereas your bucket policy can specify exact details that you want to enforce. And so I find that the bucket policies are great if you want to incorporate more defense in depth within your application. You can enforce HTTPS if you have HIPAA compliancy, and or you can also enforce that you can check a box off to say that everything on our S3 environment is encrypted with server-side encryption. So there's a number of things that you can enforce there. And again, the IAM policy allows you to just do identity federation. You didn't see any. Okay, so right. So essentially, what you can do is, sorry, there's a gnat flying at my face. Right. So you can have your Active Directory server, and you can have like specific users and groups, and you won't have to create them within IAM. Instead, you just use whatever Active Directory has, and you can attach policies to those users and groups. I don't know for certain. Maybe that's something that we can sit down and look at, after this. But yeah, off the top of my head, I'm not entirely sure if they support LDAP. Whether or not LDAP. All right. Sorry. So out of curiosity. Well, actually, let's look at how S3 actually evaluates all these different ACLs that you can create. And what it uses is something that I think is pretty neat, and it's just called default deny logic. So by default, everything is denied. When a request comes in, it says, all right, I'm going to deny this. It's going to evaluate all the policies, and then it'll say, is there an explicit deny? If there is, then it's just going to say, I'm going to deny this request. Otherwise, it'll check to see if there's an explicit allow. If there is, then it'll actually allow the request. Otherwise, it denies. Sorry about that. So one of the interesting things, though, is if you have a policy that says maybe you have an ACL that permits access and you have a bucket policy that denies access, the deny is always going to trump the permit. So again, right here, you could have multiple policies that contradict each other, but the end result will always be deny. And the beauty of that really is that by default, it's going to be secure, unless you, accidentally mess things up. So now we're in the realm of encryption now, and so looking at the server-side encryption, this is great because Amazon manages all the keys for you. They'll generate the keys, and then they'll also encrypt all of the objects that you specify need to be encrypted. So that basically means you can transfer the risk to Amazon. You don't have to bear any of that risk. You don't have to manage the keys, and this is great, especially if if you have certain compliancy that says that all objects need to be encrypted. You can do it quite simply through the server-side encryption. Yeah.
Is this encryption FIPS 140-2 compliant?
I'm fairly certain it is. I know Amazon. I'm pretty sure that that's something they've worked into their FIPS compliancy. I don't know about FIPS entirely too much, but I imagine 256-bit is probably, yeah. I mean, it would take, I can't imagine that being cracked anytime soon. Right, so the next part of this is the client-side encryption. So for the client-side encryption, essentially, right, you take ownership of the keys. But the cool thing that AWS does is they have this SDK that can help you make this process much easier. And they use something that's called envelope encryption. Out of curiosity, how many people are actually familiar with the concept of envelope encryption? Okay, so this is actually something that was pretty new to me as well. We have like maybe 3 hands, and I was surprised. So essentially what you have is you have your blob of data. The SDK will generate a one-time key, and you encrypt that blob of data, and then you encrypt the one-time key with your master key. So the only way you can obtain the one-time key right is obviously you have to have the master key. And the beauty of this is if the master key is ever compromised, you don't have to go through and re-encrypt all the blobs of data. All you have to do is just re-encrypt the one-time key. And so you don't have to spend resources or time or effort to encrypting all that. You just simply encrypt the one-time key. All right. The master key? So for client side, that's something that you provide. The one-time key is something that the SDK will generate and use, and then you just provide the master key. So like in client side, let me actually back up. So for client side, you provide the key. You have to make sure that you're securely storing it, and that it's it doesn't become compromised too easily. Looking at these two, there's actually some different use cases I mentioned, and let me actually circle back. So for the client-side encryption, this is you have to be very careful about where you use this, because if you're developing a mobile application that uploads photos or maybe some blob of data that you want to encrypt and then send up to S3, that's a cause for concern. You should pause, because that means the key must reside on the mobile application somewhere, right? And we all know the mobile the mobile environment isn't the most secure environment. It's actually, you should consider it as a hostile environment. And so if you're storing that key on there, obviously that's a cause for concern. Instead, you should look at something like the server-side encryption. But again, you may also run into situations where you can't do server-side encryption for whatever reason, because maybe you have some obligation to not share private keys with third parties. Right, so looking at Scout and how it uses S3, I'll be blunt, it's very crude. And the reason why is because looking at ACLs, I had mentioned the access control policy. Unfortunately, that actually costs money to pull down. It costs about, and it's not much, but it's 1 cent per 10,000 requests. And so when we were writing Scout, really we paused and we said, okay, well, we can't really just pass that on to the users or the operators of Scout, mostly because maybe people don't realize how many objects they have up there, and if all of a sudden they incur $100 in their bill and it's because of us, we would feel pretty, I guess, shitty. And then we looked at the IAM policies, and to be honest, they're really not too interesting, because chances are you're already aware of them already. These are all things that you probably added yourself. One thing that we could do there is maybe have you provide additional information, and then we can diff and try to highlight certain issues. But again, these are policies that you already set in place, and so it's really not too interesting. We are considering coming back to that, though. So what we do is we look at bucket policies, and currently all we do is we just dump out every bucket or object that has anonymous access due to a bucket policy. And like I said, it's very crude. But there are some other things that we want to grow into, like if you have certain objects and buckets that that should be encrypted, you can say Scout, go through these and make sure they're all encrypted. So at this point, here I have some resources, so if you guys want to check these out. I referenced the AMI research. This gentleman right here, he works for Dell. And he actually released this. It's actually a pretty cool read. And yeah, so at this point, if you guys have any questions, or you want to reach out and tell me anything about this presentation, or have some suggestions for Scout, feel free to contact me. And at this point, if you guys have any additional questions, yes?
I got one for you. I kind of got you. EC2, the Amazon Master Console, if you know anything about the Amazon Master Console, is before you do anything, where you set up S3 and EC2, you have the option of enabling two-factor authentication, which lets you use Google Authenticator on your phone. Now, there's a gotcha here, because on the root account, when it asks you to do that, it asks you to take a picture of the barcode with your phone, and then you do that and accept it and hit OK. Only that person who took a picture at that moment in time can get into your master console. So if you want some sort of failover on that, you've got to line everybody up. They all have to take a picture of the phone, and then you got to take into account what happens if everybody rotates their phones. This is your master root account, so this is your God account. It's easy for users because the root account can go change or disable the users, and you can rotate those to your heart's desire. But the root account, recovering that is impossible, so you have to really think about it. Take a picture of the screen, print it, keep it in your key repository, line up 10 people with their phones. But if you do what we did in early on NBN and replace everybody's phone, you have to realize you just lost all your master keys.
So how?
Yeah, no, that's actually a very interesting.
Yeah, you might want to add it to Rezo because that can be painful.
Well, how we deal with that? It's actually pretty simple. You just buy a hardware MFA device for $15.
Yeah, well, afford to do that.
Lock it away and create IAM accounts for everybody. And nobody ever has to use that account. That's the idea. Like if that you should never use that account.
Vice President. And they do have an API for your instances if you want to use it.
But just add to what you have said for the multi-factor authentication. So AWS has the multi-factor authentication for logging into the console, so you basically do that at home. And then recently, I think in the past few months, they announced an AMF protected API. For example, you talk about the policy with EC2, so you can set up the policy so that certain critical operations is fine with the granularity control.
Right.
For example, to shut down a virtual machine, you have to have multi-factor authentication in order to shut down a virtual machine. Otherwise, other people get your key, just shut down your machine, completely shut down your business. So you can actually specify the policy of the API, specific API.
That's actually really good insight.
Yeah, you can have it with a scoring engine, and you can easily check if MFAs and penalties and forces in policies. In policies, you might have a condition which will tell you that not allowed to be authenticated unless you use it.
Okay. Yeah, that's thank you. That's actually really great. Do we have any other questions?
I just have a general question about do they host all of their own services on site, or is it something that they subcontract out?
I don't know about that. I don't work for Amazon. I don't even know if they actually release those kind of details. I'm sure it's pretty guarded. Yes.
So, I mean, what have you found from running this? Most of the things you see, are they user implementation issues, or are they just when you generate a brand new one, it's generated in an insecure state?
Oftentimes what you see is actually just like misconfiguration or misunderstandings in their implementations. So yeah, I mean, that's really what Scout is really good at identifying.
Well, when you power up an EC2 instance, when you're configuring it initially, it gives you two options to configure it. If you select the wrong option, you just gave the world access to your instance.
Yeah.
So you have to pay real close attention when you're powering this stuff up. And then if you're using one of these community AMIs, like he just pointed out, who knows what's on that AMI, right? And there's a whole bunch of those available to you. Elastic Detector is one of them.
Yeah.
One slide.
And I failed to mention this, but so ISEC is actually having a party at 6 Lounge Rooftop. So I'm sure it's like open bar. If you guys are interested, we have invites here. You guys are more than welcome to come. And if you guys have additional questions or suggestions, I would love to hear it and talk to you. Yes, sir.
Oh, just slides, email you? Or?
Yeah, preferably.
Actually, I am going to get the slides and we will put it up on the AppSec site.
Am I supposed to trust this?
Yes.
Here's the first one. You don't read your laptop after a con? Come on, man.
Yeah, hold on.
Oh, you can send
I got my own.
send per email if you
Yeah, that's true. I could easily do that.
Send me an email, but we
How about, I'll give you this. How about that? You trust me.
All right, security consultant? Who do you trust?
But again, thanks for coming out, guys. I hope you enjoy the rest of the conference, and I hope you enjoy Austin.
Thank you.
All right.